Right, recording's on.
Where the hell's my pen gone?
Right. So we had this transformer, 500 primary turns, so N1 equals 500, N2 3000, V1 240 volts, find V2 is the question mark. Yeah. So we know that V1 over V2 is equal to N1 over N2. Now, because we're trying to find V2, the quickest way to deal with that is to rearranging this is invert both sides. So we can say V2 over V1 is equal to N2 over N1. Is that not handy or what?
Yeah, man.
And then we simply multiply the size by V1, so we end up with V2 is equal to V1 N2 over N1. Yeah?
Yeah.
And then we can put our numbers in. So 240 times N2, which is 3000, all over N1, which is 500. And you should have got 1440.
Yeah.
Yes.
Yeah. Oh, Toby Wilson, hello.
1.44
It's Toby here.
kilovolts.
Yes.
You joined us, Toby.
He's trying.
Okay.
Toby privately messaged me.
Oh, did he?
That's cute.
Very sweet.
Yeah. All right. So that's that first problem. Did you ever go to the second one as well?
No. Mac and Myers, yeah.
Yeah, I had a go at it.
Where did it go, Mike? Can you just go back up, please?
Sorry?
Can you just go back onto the other page a second?
Yeah, of course.
Thank you very much.
Alright, should we give the next one a go? So
Yeah. When Tyler's finished.
Yeah, no, we're all good.
All good, yeah?
Yeah.
Right. So the second one, well, I've got an ideal transformer with turns ratio, so slightly different, of 8:1. What that means is you've got 8 turns on the primary for every 1 turn on the secondary. Okay, so it doesn't say 800 turns and 100 turns, it just says a ratio of 8:1. Yeah, so that's how you would, so we're stepping down, right? And then we got, and the primary current is 3 amps. I1 equals 3 amps when V1 is equal to 240 volts. Calculate the secondary voltage. So V2 is the question mark, and I2 the question mark. Yeah. So we can write that V2 over V1 is equal to N2 over N1, can't we? Yeah.
And then flip it. Oh, no, there's flipped. Yeah.
Hello, Toby.
Flip it real good.
So then do the V1 N2 over N1.
Yeah. So therefore, we can convert, rearrange that to the V2 is V1 N2 over N1. So that's V1 is 240, N2 is 1 over 8 equals 30 volts. Yep. All happy with that?
Standard.
Yep.
And then we want to use the current part of the and remember we've got to have the turns ratio or the voltage ratio, whichever we use. We're going to use the turns ratio because that's been given to us. So we've got we've got to have N1 over N2 here. Yeah, because it's got to be the other way up to the current ratio. Therefore, I2 is equal to I1 N1 over N2. That's 3 times 8 over 1, 24 amps. Yeah.
Yeah.
So that's just showing you that this step-down transformer reduces the voltage from 240 down to 30 and 8. That increases the current from 3 amps up to 24 amps, i.e. multiplied by 8. Yeah. So therefore, if we talk about the VA on the primary side, we've got 240 times 3 amps, volts times amps, is equal to 3 times 24, 72, 720 VA, and then from the secondary side, we got 30 times 24, which should also come out to 720. $720. Yep. So that just proves that you got your calculations right, because your volt amperes must be the same on both sides of the transformer. Yep. Right. Let's just save those two. Just unshare that for a minute. See what has Toby got? Can you put mic on?
It's in your voice, Toby.
No, he hasn't got a mic on his computer.
Poor guy.
Yeah.
Are you on computer and phone, Macaulay? Is that what you did? What I suggested?
I'm just on phone, yeah.
just on the phone because you're on there twice or were.
Oh, I'm just on my phone.
Okay. Yeah.
New York City Dawn. Representing New York.
Take it off.
What time does this lesson end?
1:15.
What time does Omar start?
1:45.
Yeah, it's
Or-
a half hour, he said.
Half-hour lesson.
No, a half hour after we finish here.
Ah, got my hopes up.
So what time's his lesson running to?
Like 6:30, maybe.
5:45. Review of sessions, discussion of assignment 1. Oh, so we're not doing materials in that lesson.
No.
No.
Wait, what are we doing?
No.
It just says review of previous session, discussion of assignment 1, assessment of session
Is
learning.
Is
feedback.
assignment
Toby.
1 the one?
Hang on, guys.
Oh.
Can you shut up a minute? Toby, can you hear us?
Drum roll.
I think we better just press on.
Oh, wrong screen. Wardrobe open, you can see my clothes.
Right, after that, you've got another problem. 5 kVA single phase transformer, turns ratio of 10:1, fed from a 2.5 kilovolt supply, neglects and losses determined. The full load secondary current, the minimum load resistance, which can be connected across the secondary winding to give full load kVA, and C, primary current, full load kVA. How would you tackle that problem?
I'd write down each one, so the N1, N2, V1, V2, I1, I2, just to see what I've got and what I have to work out.
It's a good idea. It's a good place to start.
Thanks.
Yeah. So
Let's do
let's do that, shall we?
N1 equals 10. And then N2 equals 1.
I have to stop that share for a minute and then share my
Oh no.
iPad. Right. So what we got?
N1
Rating is
equals
10.
1.
Who's writing on my screen? Pack it in.
Probably Macaulay.
Right.
What?
There's Toby. Trying to communicate with us.
So what are we doing now? Problem 5.
Yeah.
Yeah. The one that starts a 10 kVA single phase transformer.
Oh.
Oh, like, ooh.
So we've got N1 equals 12, N2 is equal to 1. V1 is 2.4 kilovolts.
Should we change that into just a volts, or should we just leave that?
You could change it to just volts.
Also, it's 2.5.
Sorry?
It's 2.5, not 2.4.
2.4 on my screen.
No
I've got-
question.
I've got
It's part-
10 in one as well.
5 kVA and then 2.5 kV.
Oh yeah, you've got a different question to us.
I have.
Yeah,
No,
yeah,
you just
yeah.
need to scroll right down. Scroll right down on the paper. Page 15.
You are.
Page 15, the one Mike's turn.
Oh, you've done a different question. Ah,
Have I got ahead of myself?
yeah, you're
We've
on
gone to
something
the
else.
last page, yeah. Oh, problem 5 has got a 10,
Oh, yeah. That's
a 5 kVA.
right.
Which one are we doing?
No worries. We'll do the 5 kVA.
Good choice.
So our rating's 5 kVA.
Yeah. On a
5
ratio
kVA.
of 10 to 1. And then it's fed from a 2.5 supply.
Ratio is 10 to 1 then. So N1 is
Yeah.
10, N2 is 1. And V1 is 2.5 kV.
That's correct.
From that information, what can we find?
V2.
So we can find V2, can we?
Yeah, so we do N1 over N2, but we flip it, so we do N2 over N1 is equal to,
Like that?
that's the one.
If we put them in, we've got 2.5 times 10 over 1.
250 volts.
Plus N2.
Gotcha.
Agreed?
No, yeah, I agree.
Now, not knowing the load, because we got no resistance value, it just wants to know what the full load current is. Yeah? So how can we get that?
I think Taylor knows.
No, I'm going to come there and smack it in a minute. Bugger Borison is also
What we can do is say, guys, rating is equal to V2 times I2. Yeah. So that's rating in VA. So we can say 5,000 VA is equal to 250 times I2. Yeah, because it's asking for the full load current, the maximum secondary current. You can get that from the rating. You mustn't go over 5,000 VA on this transformer. Do you understand that?
Yeah.
Therefore,
When you just rearrange.
I2 is 5,000 over 250 is 20 amps. All follow that?
Followed.
Yeah.
Now it wants to know what resistance will draw that current. Yeah. So that's a simple Ohm's law. RL is V2 over I2. 250 over 20 amps equals 12.5 ohms. Yeah.
Got it.
Yeah.
So if we connected a 12.5 ohm resistor on a secondary of that transformer, we'll pull the full load current at 20 amps. And that is the maximum because that would then be 5 kVA. Yeah.
Yeah.
So how are we going to find the primary current I1?
I1 is, you can do I2 over I1 equals N1 over N2.
Yeah.
And then rearrange it.
We want I1, don't we? So we might as well put that on top.
Yeah.
Over I2 is equal to N2 over N1.
That dog.
Yeah. So I1 is equal to I2 N2 over N1. That's 20 times 1 over 1. That can't be 20 amps because where have I gone wrong here? N2 is 1. I2
I2 is 20.
20 times 1 over
Oh, one of them's 10.
8 over 10.
Yeah.
So that's 2 amps. Yep. And that's true, isn't it? Because we step down 10 times the volts. So we must step up from primary to secondary 10 times. So going from 2 amps to 20 amps. Yeah. Everybody okay with that?
Yeah.
Oh, yeah.
Yeah.
Pretty decent.
Toby, you okay with that?
Right. I don't even know if Toby can hear me because he hasn't answered me in the chat. But let's just take a look at the remainder of those problems. So what I've put in your notes this week. You've got some more problems you can try. So there's an RL circuit, an RC circuit, an RL in parallel with the C, and another transformer problem similar to the one that we just did. So there's plenty there for you to practice. And when I put the stuff up on Moodle, I will put the solutions up there. All right?
Yeah.
Yeah. I'm going to stop that share and I'm going to try and Make Toby hear me.
I really like Toby anyway, so it's alright. I'm kidding, Toby, if you can hear me.
You poke someone on this.
I mean, if
I mean, a virtual poke.
one of the two ProServe boys might have his phone number.
I can pause recording.